Hello and welcome to Scrap Paper and Philosophy. My name is Fabio, and I'm very excited to do these videos because I have a lot of scrap paper. So today we are going to do hexadecimal numbers. Look at this, just a list of hexadecimal numbers. And they are printed on one side. The other side is perfectly good scrap paper. And that's just the tip of the iceberg. So let's jump right in and begin discussing. Well, today we'll discuss the greatest book by far, hands down. No one will deny this. It's the greatest book ever written. It was written by Sir Isaac Newton. It is called, in Latin, Philosophiae Naturalis Principia Mathematica. And I know I'm getting that name wrong, the pronunciation wrong. Of course, my language is Portuguese, and in Portuguese, if you're a Portuguese speaker, give yourself a gold star because the translation is very good. Filosofia natural a princípio da matemática. And then if you're an English speaker, give yourself a silver medal because the translation's fine. It's mathematical principles of natural philosophy, but you see the word order is wrong. The words are similar, but the word order is wrong, so you only get a silver medal. Now, Newton's is very much a creature of the 1600s. He knew no standard chemistry because that was very much an invention of the 1700s and the 1800s. So I guess during the 1600s, there were four elements, and they were earth, fire, water, and air. And what Newton's going to do is he's going to have his own four elements. They are going to be distance, time, matter, and energy. But the interesting thing here is that there's no way we can relate earth, fire, water, and air to each other in a consistent mathematical way. And that's not so for Newton's system. You see, the four elements of Newton, distance, time, matter, and energy, we will be able to relate them using the formula, where is it? Force equals mass times acceleration. And of course, mass equals force divided by acceleration. And the point I'm trying to make with this formula, mass equals force divided by acceleration, is that it's a very self-referential formula. You know, when you think of measuring mass, you're applying a force to the mass that you're measuring. So that force has to pertain to the mass that you're measuring. And whatever acceleration that mass experiences, it's the acceleration of that mass. And you're using that to define mass itself. So it's a self-referential formula in a sense, I guess, just whatever. And but it can be used to relate the four quantities: distance, time, matter, and energy. And I guess now is a perfect opportunity to start using scrap paper. We have, force equals mass times acceleration. And remember that the units of energy are Newton meters, right? Energy, the units are Newton meters. So if we divide Newton meters by meters, right, energy divided by meters, I guess, we get a cancellation right there, and we're left with newtons. Well, the point I'm trying to make is that at least if we're talking about mechanical energy, energy equals distance, force times distance, right? So energy equals force times distance. And then if we divide both sides by distance, energy divided by distance, well, that's a force because the distance canceled. So there it is. Energy divided by distance equals mass times acceleration, because force equals mass times acceleration. I'm not being consistent on the cap size on the lowercase. Sorry about that, but whatever. And that's going to be very interesting, actually. If we're trying to relate energy, distance, mass, and time, because what we're going to do is we're going to say, okay, so energy divided by distance equals mass times acceleration. But acceleration is just velocity, which is a change in distance, divided by time, by a change in time, and that velocity divided by another change in time, right? And so what's going to happen here is that we're going to get energy divided by distance equals to mass times distance divided by time squared. And then you see, well, we can simplify this, of course. We can multiply both sides by distance, and then we can say energy equals mass times distance squared over time squared. Well, we can do a lot of things with this. We can, for instance, solve for time. And what we get is this. Time equals... all right. Time equals distance times the square root of mass over energy. And I know this is difficult to believe, but here we have the equation for the period of a pendulum. The period of a pendulum is equal to 2 pi square root of the length of the pendulum over g, which is the acceleration due to gravity where the pendulum is operating. Now, I know this isn't particularly, the terms don't exactly match, but the mathematical operation matches. You're multiplying a number by the square root of a ratio. And that's pretty amazing, I think. So I'll be discussing these matters further, but I'm trying to make short videos. So I guess I had quantum mechanical stuff I wanted to start talking about, but I think I'm getting ahead of myself because we haven't done justice to the force equals mass times acceleration, and how we can motivate other concepts out of this. So for now, let's just go on a song and dance about how this is the greatest book ever written. Okay, if someone asks you, which book of the Bible, Genesis 1, I don't know, I think Genesis 1 probably. I mean, which book of the Bible is the greatest book? And and then you compare it to you compare it to Newton, which is, I mean, there's no comparison. Of course, it's written in Latin, so nobody reads it. And so we'll end by going on a little song and dance of apologies to Sir Isaac Newton for not reading his book. Oh, that's only going to take a second. And so see you next video. Again, the scrap paper is gonna keep rolling. It's never gonna end. So I'm looking forward to making several of these. And bye for now.